First, let's talk about the node structure in Maya. In our studies so far, we've all more or less used some of Maya's nodes before. For example, the parent constraint node. At that time, we're actually figuring out how the parent constraint works in Maya by looking at the connection status of that constraint node. The structure of nodes in Maya is very similar. Let's quickly draw it out. We'll draw a small box. This small box represents our node. First, it has input attributes. The input attributes, depending on the type of node, their names might be different, and the number of them can also vary. Here, we'll just simply call them input 1 and input 2. Then there's the node itself. The node itself, it performs calculations using these input attribute values. This calculation could be simple or complex. In the end, it gives the result to the output attributes. We'll just write output here. Just like the input attributes, depending on the node type, there can be one or more output attributes. Their names can also be different. Let's first look at the input. These input attributes, we can control them in various ways. How to control attributes? We've talked about this before. We can use direct connections. We can use set-driven key. We can use constraints. We can even just manually assign a value to change its result. Then, when we finally get an output result through the node's complex calculation, we can use this result to connect to other attributes and achieve the effect we want. So here, let's use a very simple math formula as an example. What is this math formula? It's just 1 plus 2 equals 3. If we were to write 1 plus 2 equals 3 as a node, then the node itself would be an addition operation. It gets a final result by adding our two input attributes together. So input 1 would be 1, input 2 would be 2, and the final output result would be 3. We can also change the input values if we want. For example, let's change this to 4 and input 2 to 5. Then the final result is 9. Next, let's go back into Maya and take a look at how nodes actually operate inside Maya. I'm sure when we first started with Maya, we all heard this saying, Maya is a node-based software. What does this mean? When we're actually modeling or animating, we might not have truly felt the logic of how Maya's nodes work. So let's take a look together here to help us get a better understanding of it. Let's use modeling as an example. I'll create a cylinder in my scene. We can see in my node editor, it's showing 3 nodes. Let's look at them one by one. First, P-cylinder1. This node has translate, rotate, scale, and visibility attributes. We're very familiar with this. This is the transform node we talk about. It represents position information in the 3D scene. Corresponding to that is our P-cylinder shape 1. We're also familiar with this node. We mentioned it when we talk about transform nodes and shape nodes. This node determines what this object actually looks like in the 3D scene. If we go to the outliner and turn on shapes in display, we can also find this node. This node is a child of our transform node. And if we select the transform node, we can also find it under the shapes tab. Now there's another node here we're not familiar with, this polycylinder one. What is this node? Let's open it and see. It has a lot of attributes. Let's try changing its attributes and see. Let's turn on wireframe unshaded. If we change radius, we see the cylinder's diameter changes. If we change its height will change. And if we change its subdivision height, the number of segments in its height will also be different. So what is this node really? This node is actually a preset for a cylinder shape. By changing these attributes, we can make it form a different cylinder. Let's look at its actual node connection. Here, the cylinder shape preset, its output result is connected to an in-mesh attribute on the shape node. And that's what causes the shape node to finally appear as a cylinder. And if we look back at the shape preset, this polycylinder 1 node, we've talked about this, it has some input attributes. We can adjust its values. Then inside the node itself, it will perform some complex calculations to actually compute the result of a cylinder shape. It assigns this information to the shape node, which finally appears in our scene as a cylinder. When we were talking about transform nodes and shape nodes, we mentioned that the shape node's name, P cylinder shape 1 is actually meaningless. It's not just because we call it cylinder, it has to be a cylinder. Where does its shape actually come from? It's actually determined by this in-mesh attribute. So something we can do here, let's replace it. Let's stop using this cylinder preset node. Let's swap in a different preset. Here I'll create a polycube. This is a preset node for a cube. Similarly, it has its own input attributes. Let's not worry about those. Let's take its output result and connect it to our shape node's in-mesh. Now we can see my shape node has become a cube. And here, we can similarly make adjustments to its width, height, and depth. And we can also change its subdivisions. Our original cylinder shape preset node, polycylinder1, isn't needed anymore. Let's delete it. So next, let's continue our modeling work. Let's add an edge loop. After we add an edge loop, we can immediately see that not only did an edge loop get added in our viewport, but also in our node editor. Between the cube shape preset polycube1 and our actual shape node, another node has appeared. This node is called polysplitRing. It's just an add edge loop node. This node is used for adding edge loops. Let's look at its connections. Here, our original cube's shape information is fed into this add edge loop node. It has an attribute called input polymesh, then through the node itself. As we can see, it also has some attributes. For example, weight. Weight indicates where to add the loop. For example, if I change this weight value, we'll see this edge loop's position changes between these two limits. It also has some other attributes. By changing the values of these attributes, it will have a different calculation result. But in the end, look, this calculation result, this output, it still outputs shape information, which is finally connected to the shape node's in-mesh, and finally appears as a cube with an edge loop. Let's keep going. Let's choose to smooth it by one level. Now let's look at our connections again. This time we'll find that between our add edge loop and shape nodes, yet another node has appeared. This node is called polysmoothface. Here, similarly, its input is the shape information from the previous node, and it outputs its shape information, which finally connects to the shape node and appears in our viewport. This is actually Maya's fundamental operating logic. Every step we take in Maya is really just adding a node. And then through the node's calculations, it connects the previous result to its input and then connects its output to the next node. This is how it's achieved. If we look at this shape node, it has history under it. I'm sure we're all very familiar with history from learning modeling. So what is history really? It's actually just these corresponding nodes that ultimately act on the final resulting shape information. Look, polycube1, polysplitRing, and polysmoothface. If we look at our history, it's really just these three. So what happens if we delete its history? Let's select our shape node, or selecting our transform node is fine too. And I'll delete history. After deleting history, we'll see all those previous nodes are gone. What happened? It took all our previous calculation results and baked them into the shape node's in-mesh attribute. It's like we manually assign a value to in-mesh. This way, those previous nodes no longer have a function, because we've already saved their final calculated result. We don't want to see any more changes. So automatically we delete these nodes. That is the effect of deleting history. So that was a brief introduction to the basic logic of node connections in Maya. What we'll talk about later, like utility nodes, or even more complex rigging logic in the future, is all built on this fundamental logic of node connections. We hope this section's explanation will be helpful for your future learning. See you in the next video.